Hi everyone, welcome to my channel, Tutorlini Test Prep. Today we'll be going over Ottocento number 3, confidence interval and margin of error. The goal of the Ottocento course is to teach students everything they need to know about the digital SAT math exam. Please see the link in the description to download this video's worksheet for free. Let's get started. Okay, so very first thing, we're probably going to have to do this at the beginning of most of the statistics videos. Let's just quickly talk about what the difference between a population and a sample are. So a population is the entire group of individuals we want information about in a statistical study. And the sample is the subset of individuals in the population from which we actually collected data. So you don't need to know these definitions. Perhaps this picture will provide some clarity. So you see on the right, those 3 people in our sample, those are the people we're going to survey, we're going to ask questions about to include in our study. They were drawn from a larger group. That larger group that the sample was drawn from is your population. So let's say I took a random sample of 100 residents in Ireland. My sample is the 100 residents in Ireland, and the population is all the residents in Ireland that could have possibly been picked. Okay, skill number 1 is to compute and interpret the confidence interval. So to find the confidence interval, we're going to use the following kind of equations, you could call them. Sample mean plus or minus the margin of error. Or if it's a proportion problem, we use the sample proportion plus or minus the margin of error. Now note that these are not, it's not like the quadratic formula where you get 2 numbers and those are both possible answers. No, these are telling you bounds for a range of values for your confidence interval. So I'm going to try to help illustrate that with this picture. So let's say we have a sample mean. It's in the middle right there. And the margin of error is like, let's say 4 units. So we subtract 4 units to get the lower bound, and we add 4 units to get the upper bound. And everything in between those 2 blue fences is our confidence interval. We also call these guys sample mean and sample proportion. We call those in statistics a point estimate, so that we don't need to keep saying sample mean, sample proportion. We just collectively refer to both of them as a point estimate. You're going to see this word estimate on the test a lot, and you're also going to see me later in the video refer to these as a point estimate. So just don't let that confuse you. So mean is just the average in the sample. Sample proportion is just the proportion in the sample. Okay, so how do we interpret the confidence interval? Well, we're generally going to do something like this. The true population mean or proportion is plausibly, that word just means likely. You don't have to write that. You're going to see that word a lot on the SAT. Between the lower and upper bounds with their units. So we're going to go in and replace whatever the true population mean proportion is in context, and we're going to replace the lower and upper with their units to this kind of general interpretation. Great. Okay, so the steps, let's see. So as with any statistics conclusion question, you want to make sure the sample was selected at random. If it's not selected at random, you can't draw any conclusion about the population. 2, we're going to identify the population. Normally, these are the words right after when the sample is mentioned. We'll go over an example in a second. We're going to actually calculate the confidence interval by doing our point estimate plus or minus the margin of error. And then we're going to interpret the confidence interval using the interpretation we just went over. These questions, you can't write like 3 sentences for an SAT question, so these are always going to be multiple choice, although some of the ones in the slides are not multiple choice. Okay, so a random sample of 200 high school track runners in Somerset County was found to have a mean weight of 125 pounds with a margin of error of 3 pounds. Compute and interpret the confidence interval. So first I check to make sure it's random. And then I look right after 200 high school track runners in Somerset County. So I bet my population is all high school track runners in Somerset County. So that's probably going to be important later. And now we're going to compute the confidence interval. So this is a mean problem. So we're going to do sample mean plus or minus the margin of error. The sample mean is 125, margin of error is 3 pounds. And we're going to do 125 plus or minus 3. So 125 minus 3 gives us 122, and 125 plus 3 gives us 128. So those are our lower and upper bounds. We always put the lower bound first, right? Put them in order. You could write this using inequalities or what's called interval notation, but the SAT is never going to do that. So you can just do it using words like if you want to use the word to, or you could say between, whatever you want. I just like to use the word to. I think it's like TO. It keeps it simple. All right, so let's see. Now we got to interpret it. So the true population mean is plausibly between 122 and 128 pounds. And we need to now replace true population mean with whatever the population mean is in the context. So what we're going to do is we're going to remember, the population is all high school track runners. So it's the mean weight of all high school track runners in Somerset County. I just word for word copy that part about the population from the question. Is plausibly between 122 and 128 pounds. Let's go ahead and do an example at the whiteboard. Okay, completely forgot that I had the first two skills grouped together for the example. So let's do this one really quickly, and then we'll do them both together at once at the board. So picking the plausible value, not so bad. All you're going to do is you're going to find the confidence interval the same way as before. Then you're going to see which answer choice falls within the bounds of your confidence interval. So super quick. And again, these are always multiple choice. So super quick. We're just going to do the same exact problem as before. Our confidence interval was 122 pounds to 128 pounds. So we just examine all of these and see which one is between 122 to 128. And the only one that is B, 127. So you see, not so bad. Let's go over both of them at the whiteboard now. Okay, so let's see. Let's take a look at this problem. We're going to do our first, let's just make sure they were chosen at random. They are. It says our population is just 100,000 people in a town. That could be a helpful piece of information later. And it tells us 42% of people. So that's a proportion. So when you do proportions, you typically can you can divide by 100 to make it a decimal, but you typically can just leave it as a percent. A lot of times in the answer choices, they leave it as a percent. So that's what I'm going to do here. So we're going to do 42% is our point estimate, plus or minus the margin of error. So the margin of error is 6%. Again, these numbers aren't so bad, but you're going to see later we're going to have ones with messier numbers. So let's just go over really quickly. So 42 minus 6, and then we're going to do 42 plus 6, and that gives us 36 to 48. So 36% to 48% are going to support the legislation. Okay, so we're all good there. Now it wants us to interpret it. So we're going to say something like this, the true population proportion is plausibly or likely between 36% and 48%. Now we got to replace that true population proportion with whatever it is in the problem. So I'm going to say the proportion of people in the town who support the legislation is plausibly between 36% and 48%. Okay, let's look at this second part. So notice how it doesn't want us to find a plausible value for the proportion. It wants us to find a plausible value for the total number of people in the population. This is something we'll go over more of in a future video, but to find the expected, we're going to do the proportion, the expected number of people that would vote. We're going to do the proportion times capital N, which is the population size. Little n is the sample size. So we're going to change this confidence interval to votes. So let's first divide them by 100. So it would be 0.36 to 0.48. And now we're going to multiply each of those proportions by the population size, which is this guy, the population of 100,000 people. So let's go ahead and do that. So let's see what we get. So 0.36 times 100,000 and 0.48 times 100,000. And we get 36,000 to 48,000. So that is now, let's go back here. That is now the number of plausible values for the people who support the legislation. So now we just look at the answer choices. Are any of them between 36,000 and 48,000? Yep, looks like the only one is 47,500. 25,000 is way too small. 50,000 is too big. And 35,000 is just a little bit too small. Technically, if we had 36,000 and 48,000 as answer choices, those would be excluded because we don't include the endpoints. However, you're never going to see that on the SAT. They're always going to make it obvious. There's always going to be one that's literally in between those two numbers, and that is the only one that can be the right answer. So they're probably never going to give you like 36,000 or 48,000 as answer choices and like expect you to know that you're supposed to exclude those. You don't have to know that. I'm just mentioning it because I figured someone in the comments will probably ask. Great. That's it for the examples here. Let's move on to the next skill. Okay, everybody, skill number 3 is mean/proportion and margin of error from the confidence interval. So everything we just did, we're going to do it in reverse. I've only seen this tested like maybe once on the SAT, but again, it's such a quick thing to go over, and you never know. A lot of you guys can probably figure this out using just intuition, but maybe this will help. So you see how the point estimate is in the middle of the lower and the upper bound? Well, to find the middle, what we do is we use the midpoint formula. To find a midpoint, we add up the two numbers and divide by 2. So that's how you're going to find the point estimate, is you do the upper plus the lower and then divide it by 2. So you add them up and divide by 2. That tells you your midpoint, which is your point estimate. Now your margin of error is half the distance between upper and lower. So you can do the absolute value of the difference, or you can just do upper minus lower and then divide it by 2. So if you add them and divide by 2, you get the point estimate, and if you subtract them and divide by 2, you get the margin of error. Researchers took a sample and found that the proportion of Americans who voted for candidate A was plausibly between 48% and 54%. What is the sample proportion? What is the margin of error? Okay, so to find the sample proportion or the point estimate, we're going to add them up and divide by 2. And that should give us 51%. And if the question wanted you to write it not as a percent, as a proportion, as a decimal, you could put 0.51. Just divide by 100, as we talked about in the percents video. And for the margin of error, we're going to do upper minus lower and then divide by 2, which should give us 3% or 0.03. Let's do a quick example at the whiteboard. Okay, researchers found that the mean digital SAT score was plausibly between 980 and 1100. Okay, so that is a confidence interval. And to find the sample mean, I'm going to add these up and divide by 2. And then to find the margin of error, I'm going to subtract them and divide by 2. And let's see what that gives us. So 1100 plus 980 over 2, 1100 minus 980 over 2. Okay, so we get sample mean of 1040 and a margin of error of 60. And let's go back here. And it's always wise when you do these guys. So these would be our answers. It's always wise to just do a quick check to see if you get what you started. So 1040 minus 60 gives me 980, and then 1040 plus 60 gives me 1100. So just do a really quick check before you move on. Okay, great. Let's move on to the next skill. Okay, so skill number 4 is sample size and margin of error. Sample size is just a fancy word for the number of people that you collected data from in your study. So in the running example we did before, I think it was 200 runners. So the sample size would be 200, right? Not to be confused with the population size. The sample size is just the number of people or things that you collect data from. So here are the concepts. So sample size and margin of error are inversely proportional. So a bigger sample size means a less error, and a smaller sample size means a bigger error. Hopefully that kind of makes intuitive sense, right? Like, think about it. If you did a study where you asked 50 people, and then you did a study where you asked 1 million people, which one's going to be more accurate? The one where you asked 1 million people, right? So the more accurate one has a lower error. Anyway, this box sums it up pretty quickly. They are inversely related. So as one goes up, the other goes down. Now, I don't think I might include a question on this, but I'm not sure if I've seen this tested. Variability or standard deviation We haven't talked about that yet. I'm going to make a future video on it. Those two things are directly proportional. So if standard deviation is higher, the margin of error is also higher. If standard deviation or variability is smaller, the margin of error is also smaller. I've only ever seen the top one tested, so I would just worry about this one, hence the name, sample size and margin of error for the skill. I'm going to put a question mark next to this guy. I don't know if you have to know this. I'm just including it for the sake of being thorough. Really, that top box is what's more important, and that's what this next example is going to be on. So sample A has a margin of error of 2 inches. Sample B has a margin of error of 8 inches. What is the most likely reason that sample B has a larger margin of error? Okay, so margin of error and sample size are inversely related. So if it has a larger margin of error, it probably has a smaller sample size. Now, this could be phrased one of two ways in the answer choices. They could say sample B included fewer fish, okay? Or they could say the opposite, which is saying the same thing. Sample A included more fish. So that can get really confusing. But that's kind of the gist of it. So just remember, margin of error and sample size are inversely related. If you ask more people, your study becomes more accurate, so the error goes down. Great, let's do another quick example at the whiteboard. Okay, so we've got two different samples, and they report to us the mean and the margin of error in the table, and they want us to explain why the margin of errors are different. So right away, looking at these answer choices, remember the only two things that affect margin of error that we talked about. The big one is sample size, right? And the other one is variability or standard deviation. So anything that doesn't have to do with either of those two things, probably wrong. So there's an answer choice here. Sample B was selected after sample A. That has nothing to do with it. And sample A has a larger mean than sample B. Again, that also has nothing to do with it. So we got to figure this out. So why don't we make a little table? This will be the sample size. I'm going to add like a column to the table because I hate the way they phrase it, because sometimes the way they write it is the opposite of how I think of it in my head. So I'm always like scared that I'm going to make a mistake just because, not because I don't understand, but because they wrote it differently than me. It would be really cool if there were questions where you could actually write like 2 or 3 sentences and, but anyway, and just come up with it yourself. Anyway, so let's see. So, okay, so this one has the bigger margin of error, and this one has the smaller margin of error. And remember, margin of error and sample size are inversely related. So the one with the bigger margin of error has the smaller sample size, and the one with the smaller margin of error has the bigger sample size. Okay, so let's see if we can find one that supports that. The size of sample B is less. No, B is the bigger one, so that is wrong. The size of sample B is greater. Okay, B is greater. It's the bigger one for sample size. That makes sense. Great, so the answer is D. So let's just do one final check. Does that make intuitive sense? Okay, sample B is greater. It's got a bigger sample size, so it's got a more accurate study, so the error should be smaller, which it is. Seems like we did a good job. All right, let's go back to the slides. Okay, everybody, so we're about to get ready for the final review. Remember to download the free final review worksheet using the link in the description. Try to complete the worksheet yourself before watching the rest of the video. And be on the lookout for a pinned comment with more helpful links about today's topic. Okay, let's go back to the board and get started with the review. Okay, question 1. First, always just going to make sure it was random, which it is. Okay. All right, we have a point estimate proportion of 0.57 and a margin of error of 0.09. So our confidence interval is going to be 0.57 plus or minus 0.09. Okay, let's quickly figure out what that is. So lower bound first. 0.57 minus 0.09. 0.57 plus 0.09. So we should get 0.48. To 0.66. And let's go back here. So the true population proportion should be very likely or plausibly between 0.48 and 0.66. The only one that even comes close to that is B, right? I mean, none of these other ones even mention both of the numbers, so that I feel like that's kind of a giveaway that they're all wrong. Great, let's keep going. Okay, first I'm going to check to make sure it's random, and then if you want, you can, highlight the population. I think it's the all digital ICT test takers from Toronto, and they give us a point estimate, a sample mean of 550, and with an associated margin of error of 40. Okay, so we are once again going to do our mean or point estimate, 550, plus or minus the margin of error, 40, and that should give us 510 to 590, which I think is right. And right away, we're kind of already gravitating towards answer choices that mention those two numbers. This actually has nothing to do with it. We don't need all test takers from Canada. All we care about is the test takers from Toronto. So it actually has nothing to do with it. Not only does it not include the numbers, it has nothing to do with it. As long as the conclusion we're trying to make is about Toronto, the test takers from Toronto, which it is in the question, right? We're good. So we don't need to worry about that. So B and D are both looking pretty good. But remember, the confidence interval just tells you that it is plausibly or likely between these two numbers. It does not tell you that it is certainly between these two numbers. So this one is wrong too. So the correct answer is D. It is plausible that the mean score is between 510 and 590. Great. Okay, let's keep going. So this one. So we have a sample consisting of 940 adults. They were selected at random. And the population is adults who own tablets. All adults who own tablets. Okay, so we have a point estimate of 23%. And the margin of error is 4.78%. So let's kind of just do that down here. So 23% plus or minus 4.78%. Definitely not going to do those numbers in my head. So let's see what we get over here. So 23 minus 4.78 and 23 plus 4.78. So we should get 18.22. to 27.78%. And you guys see what I'm saying? How they often don't make you change it to a proportion. They just leave it as a percent. That's a pretty common thing. All right, so right away, I mean, any answer choice that does not mention those two numbers, is both those numbers, is kind of out of the running. But let's just kind of go over more why they're wrong. This one says the sample did not include all the people who play video games. That doesn't make any sense. We're not trying to study the people who play video games. We're trying to study the people who own tablets. The video games is just a characteristic of them. So we don't really care about that. So that's definitely wrong. C, less than 18.22% of all adults who use tablets. That's not right. I mean, that's just, that's not what the confidence interval tells you. It's got to be between the upper and the lower bound. So those are both wrong. Okay, so A and D, let's see what the difference is. They look pretty similar. Although I noticed this one says all adults who own tablets. I spelt that wrong. I'm going to have to fix that. Let me just mark that for later. Okay, and so that looks good. That's talking about the population we care about. But look down here. It says all adults in the sample. That is wrong. Remember we said the confidence interval tells you about the population. We actually already know that the sample proportion is 23%. It wouldn't make any sense to say it's between 18.22 and 27.78%. We know it's exactly 23%. So the confidence interval doesn't tell you about the sample. It tells you about the population, which A does a better job of describing, minus my little typo, which I will fix in the worksheet that I sent to you guys. All right, great. A looks like the right answer. Okay, a random sample of 10,000 PC gamers was selected and surveyed. Okay, so we once again, we have a random, and I believe the population is all PC gamers. And let's see, we have a point estimate of 472, of a mean of 472 gigabytes with an associated margin of error of 33 gigabytes. So we're going to do confidence interval 472 plus or minus 33 gigabytes. And our confidence interval is, let's see what that is. So 472 minus 33 and 472 plus 33. Should get 439 to 505. So 439 gigabytes to 505 gigabytes. And let's see, so we have to pick the plausible value. So we just have to pick one that is in between those two numbers. So let's see. Seems like the only one is 440. These ones are too small, and 507 is too big. So you see they don't include any of the endpoints. It's just very clearly one of them is in the middle. Great. Okay, we got one more like this. So it's chosen at random, and it's the population is 500,000 people who live in a city, and they give us a point estimate of 16% with a margin of error of 5%. Okay, so we're going to do confidence interval is 16% plus or minus 5%. Which is 11% plus or minus 21%. And they don't, unfortunately, they don't want the proportion. They want the total number of people in the city who support the bill. So what we're going to do is we're going to change this to a proportion. So divide by 100. You could just do that on your calculator if you're not sure how to do it. 0.11 to, oops, that's not supposed to be plus or minus. That should be a 2. To 0.21. And then remember what we said. To find the total number of people, we just multiply the proportion times the population size. Not the sample size, not the 10,000. The population size, the 500,000. So let's go back over here and do 0.11 times 500,000. And let's do 0.21 times 500,000. And we get 55,000. The confidence interval for votes is 55,000 to 105,000. Great. Looks good. Let's get rid of this. All right, so now we just have to see which one is plausible, which one is between 55,000 to 105,000. So seems like the only one is C, 100,000. 40,000 and 50,000 are too small, and then 110,000 is too big. Great. Okay, 6. Okay, so this is what we were doing before. So we're going to try to find the sample mean. So to do that, we just add up the bounds and divide by 2, upper plus lower. And for the margin of error, we're going to do upper minus lower. So 560 minus 490 over 2. So let's see what that gives us. So 560 plus 490 over 2. And then 560 minus 490 over 2. Okay, so that should be a sample mean of 525. And is the margin of error is 35. And I would always just do a quick check. Does it get you what you started? Okay, 525 minus 35 gives us 490, and then 525 plus 35 is 560. Okay, so it seems like we did a good job with that. So great. That is it for that one. Those are our 2 answers. Let me put a box around that. Okay. So same deal. So the sample proportion, we can just leave it in terms of percent. So let's do upper plus lower divided by 2. And then for the margin of error, we're going to do, we subtract them and divide by 2. And let's see, 76 plus 70 divided by 2, that's just 73%. And 76 minus 60, that's just 3%. And again, just do a quick check. 73 minus 3 gives you 70. And then 73 plus 3 gives you 76. So we did a good job. Great. Let's keep going. Almost done. Okay, so it wants us to explain the most likely reason that sample B has a larger margin of error. So let's go over here, and right away I'm seeing things that have nothing to do with margin of error. So these two at the bottom, greater percentage of test takers, the sample proportion being higher, that has nothing to do with it. And when the sample was selected, that has nothing to do with it. So both those are wrong. So both these are talking about sample size. So let's make a little chart here. So this is the bigger sample margin of error, and this is the smaller. And remember, we said sample size and margin of error are inversely proportional. So the bigger margin of error has the smaller sample size, and the smaller margin of error has the bigger sample size. Now we just need to carefully read both of these and make sure that it makes sense with the way that we want to write it. It's kind of frustrating about multiple choice. Anyway, so sample A included more test takers than sample B. Well, sample A had a bigger sample size, so that one seems to make sense. Sample B included more test takers than sample A. No, that doesn't seem right. Because we found out that sample B had the smaller sample size, so that doesn't seem right. So it's got to be A, and let's just do one final check. Okay, so sample A had a smaller margin of error. That means it had a more accurate study, which means they asked more people. Good. Okay, question 9. Let's see. Table shows the estimated mean lifespan, blah, blah, blah. Okay, and it wants us to do a very similar thing. Why is the margin of error greater than the margin of error for sample B? Okay, so let's once again look at the answer choices. I'm already seeing these first two talking about things that have nothing to do with it. And the correct answers are talking about sample size. So let's make a little table. And this one has the bigger margin of error, and this one has the smaller margin of error. So this one must have the smaller sample size because it's inversely proportional, and this one must have the bigger sample size. So let's see which one makes most sense. Sample A is less than the size of sample B. That actually makes sense. Sample A does have the smaller sample size. Sample A is greater than the size of sample B. That does not make sense. Sample B is the bigger one. So that one is wrong. Do one final check. Okay, big margin of error. Less accurate, so they must have asked or studied less trees. Good. Okay, let's look at question 10. Okay, so this one's about digital SAT on a laptop and how it affects your math score. So it wants us to independently, notice how it says either. It doesn't say both, it says either. So it wants us to independently check each of these explanations to see if they're right. So let's do that. Let's do the sample size one first. Okay, so this one has the smaller margin of error, and this one has the bigger margin of error. Sample size and margin of error are inversely related. So the smaller margin of error means a bigger sample size, and bigger margin of error means a smaller sample size. And let's see, sample B included fewer test takers. Oh, well, sample B had the smaller sample size. So that seems to make sense. Now, I'm going to erase all that. Let's independently do the same thing, but for standard deviation, just do them totally separate of each other so that one isn't causing the other. Okay, so variability, standard deviation, is directly proportional with margin of error. So a smaller margin of error means a smaller standard deviation, possibly. That's what it says, just says possible reason. And a bigger margin of error means a bigger standard deviation, possibly. So it could be due to that. So let's see, sample A had a smaller standard deviation than sample B. Yes, it did. Or yes, it could have. So either of those could be reasons that explain this difference in the margin of error. So the correct answer is either 1 or 2. Really just sums up what we're learning about in the video really well. I don't know if you'd ever see a question like this in the actual test, but again, it gets you thinking about the concepts, and that's the goal with these worksheets. Okay, awesome. I think that was the last one. Let's go back to the slides. Okay, everyone, time to wrap up. Thank you so much for watching my video. Please comment below your thoughts on the video and worksheet. Did you find them helpful for your studying? Like the video and subscribe for more digital SAT math content. And if you need tutoring, my website is linked in the description. I tutor SAT math and all math subjects from about 7th grade to AP/early college level. Thanks for stopping by, and good luck studying.